In example number 2, I'm given, is quadrilateral ABCD a rhombus, and explain. So my plan is to show that ABCD is a parallelogram and then show that it has 4 congruent sides. Now to show a parallelogram, there's lots of different ways I could do it. I could show that the diagonals bisect, I could show that the opposite sides are congruent, I could show that the opposite sides are parallel. Now I'm going to be clever about this. I'm going to say if I show by the distance formula that the opposite sides are congruent, then I will already have found all 4 sides using the distance formula, so I can go ahead and compare and see if they're all 4 sides being the same, which would make it a rhombus. So my plan is to find the distances of AB, and I'm going to compare that to its opposite side CD, and then I'm also going to go back and I'm going to find the distance of BC, and I'm going to compare that to its opposite side AD. So I'm going to use the idea that if the opposite sides are congruent, then it's a parallelogram. So let's start there. Again, I like doing the method for finding this by sketching over and down and just counting or subtracting those coordinates. So the distance here from A to B going from 0 to -2 would be 2, and going in the y direction from 4 to 0 would be a distance of 4. So the distance of AB is going to be the square root of, oops, not 0, 2 squared plus 4 squared, which is equal to the square root of 4 plus 16, which is equal to the square root of 20. I always get in the habit of simplifying my square roots, so this would be the square root to root 5. I'm going to do the same thing for CD. I'm going to count down and across, and usually I can tell by the numbers. So from 2 to 4 is a distance of 2, and from 5 to 1 is a distance of 4. Here's usually where I save myself a little bit of work. Those are the exact same x and y distances as AB. So I could write square root of 2 squared plus 4 squared and then the rest of it, but I already know that this is equal to 2 root 5 because I did the work right above it. So I have effectively showed, using the distance formula, that AB is congruent to CD. But that doesn't prove that it's a parallelogram. To prove that it's a parallelogram, I have to have both sets of opposite sides being congruent. So I'm going to go back now and do the exact same thing to find BC and AD. So to find BC, I'm going to sketch up and across. Now I only went from 0 to 4, so that's a distance of 4. And I went from 4 to 5, which is only a distance of 1. So BC is going to equal the square root of 1 squared plus 4 squared, which is equal to 1 plus 16, which is the square root of 17. And it's okay to have a number as a distance of square root of 17, because remember, we're just going to try and check and see if they're the same. So now I go back and I see if those distances are the same from A to D. So from D, I draw down and over to A. And I notice that from a height of 1 down to 0 is a distance of 1. And from -2 to 2 is a distance of 4. So here again I can see I'm going to have the same exact numbers, 1 squared plus 4 squared, which we already figured out is the square root of 17. So this is not a shortcut, this is just not duplicating work that I've already shown. So again, I can show right here that BC is definitely congruent to AD. So what I have shown is that it is definitely a parallelogram because both pairs of opposite sides are congruent. But that's just a parallelogram. I was trying to see if this was a rhombus. So now I look at this and I say, well, a rhombus has to have 4 sides that are congruent. And if I look back at my numbers, I've got the square root of 2 root 5 and 2 root 5, but that is not the same thing as square root 17 and square root 17. So using the same distances that I already calculated, I can see that this is definitely not a rhombus. And that would be my answer here. So my explanation is, it is a parallelogram because both pairs of opposite sides are congruent, but it's not a rhombus because all 4 sides aren't the same. And those are the things I'm looking for in your explanations. Now I would write that out a little bit better here, but I don't have enough room. So please understand, the explanation is, this is not a rhombus, and it's only a parallelogram because both pairs of opposite sides are congruent, but not all 4 sides are the same. And you can see that I verified that with my distances.